This is the work cell that y'all are building. I don't remember which robot it is. I could go look. And then we're building a work stand and then a work piece that we're going to put on top of it. Originally, you're going to build a torch, and then you're going to import a model or import a torch, right? It's already there. Then what we're going to do is we're going to start programming this thing to do a weld. We're going to have to modify the procedure a little bit because of they built it. They wanted the work stand to be up like 600 millimeters, and we dropped it down to 300, right? And then the way they teach it, they teach you to put a weld point right here. And of course, if you go from here to there, guess what you're going to do? You're going to go right through the workpiece. So normally, the way we teach it is we'll teach our start position. It's going to be a start position where we're just going to take the tool and rotate it down to 90 degrees. And by the way, there's no, on MotoSim, there's no guesstimating about these angles. So what we can do when we bring up our this right here, this is our teach pendant, and this button right there allows us to look at the position of the robot. This is pulse, so this is actually 0 position for this robot. So if you ever want to go back to 0 position, you can just come into pulse and just hit 0 and just tab through them like that, and it'll pop that robot right back up to 0 position. Or I can come up and I can look at joint angles. So notice that L is setting at 90 degrees, and there's no guesstimation for that, right? You understand that? Because if you say move this down 90 degrees, if the instruction says move this to 45 degrees or whatever, then by George, it better be what? 45 degrees when I come up here and we do grade when I grade it. Okay, y'all understand that? Also, what we have here is we have a positions where we actually look at a Cartesian system, the position of the robot in a Cartesian system, which would be X, Y, Z. I can't remember. This is around X. So X goes this way. So this would be yaw, and this would be around Y. This would be pitch, and this would be rho. Took me a long time to figure out what these RXs and RYs and RZ means. But X goes this way, right? It goes out from the robot. So if I roll around X, it's going to be like this, right? You understand? Y goes this way, so if I roll around Y, it's going to do this way. So that's what that means. And of course, Z is a roll, no matter, it just spins around Z. Of course, Z does like this, so that's going to spin it like that, right? Okay. So that's what that means. So R, this should be around X. So this is actually what we call yaw, and this would be pitch, and this would be rho. Okay. So what we can do is that once we have our tool center point set, and once you put your tool center point, then the tool frame should move down to the tool, tip of the tool. By default, it was up here in the center of the flange. And that's what you do. So to set the tool center point, I'm not even really sure if you can teach it on MotoSim, but you can import it. So later on, when we get playing around, we're going to move over to the HJ3 robot. And what we'll see is that we go over there and we can download the parameters off that robot. So what that means is that if I teach a tool over there, and then I model the same tool over here, then I can go over there and teach it over there and download those parameters into MotoSim, which is pretty neat. So we can literally teach a tool over there and download it into here. Are we okay? Yeah, did y'all bring y'all's USB drive? You know you're going to lose points if you don't have one today. I was supposed to have it by today. You can use it, but we're going to lose points on your thing for not having your required supplies. So what we can do, another thing, did we talk about OPL? OLP, excuse me. They're keys.
Okay. Oh, you can use them?
Yeah, use any one you want to. Huh? Well, once we have our tool center point set, what that allows us to do is to send the robot to any position I want to by just touching on things. So when I set up OLP, then what we can do is we can say where we want to go to. So right now I want to go to the vertex. Now what's the vertex? That's the exact corner, right? You understand? Now we're not worried about collision because we're just sending that. I'm going to send it to a model, the vertex, and once I turn this on, if I come over here and just touch where I want to go, the robot moves to that exact point.
Does it record this?
No, it don't record it. It's just like jogging the robot, except, so when you jog the robot, that don't record anything, right? You understand? I can get over that robot, I can move it all over the place, and that's not being recorded. That's what we call a continuous path robot. Our robots are point-to-point robots, which we jog it to a point, and then how does it remember it? We teach it, right? You understand? Of course, normally, if I was to run this from there to there, it's going to go through here. So normally, what do we do? Well, what we do is we move it out, and we teach what we call staging, right? Okay. And that's to get us down into position. Normally get to the staging point, we use joint moves, and then from the final staging point into the actual workpiece, we use linear moves, right? Okay. Then if I wanted to bring this back 15 millimeters, then what would I do? Well, what I would do is I would come up here and bring up my robot position. And I see my Z right there, right? Don't understand that. So this is Z. And what could I do? I can bring it up 15 points, which would, or millimeters, which would be what? Would be 105. Okay. Or I could do it here, but the problem here, if you do it this, it's going to jog relative to the world. So what I would do is I would come over here and put it on tool. Now it's going to jog relative to the tool, right? You understand that? And then I would come up here and go either the slow to inch, and I'm going to come over here and I'm going to go Z minus. So now what's going to happen, it's going to come up relative to the tool, right? Don't understand. But what it did is at this angle right there, so it came up like this, right? Another thing that I wanted to make sure y'all understood. So I want to go back. I'm going to go to pulse. What am I going to do? Hit 0 tab, and I can set the robot just like that, right? So remember that when you're trying to teach what we call the start position, because this is the what? This is the start. This is the start position.
What it does is stop tearing up stuff.
What do you mean tearing up stuff? It's a simulation.
Without simulated collision.
Oh, it would collide. We don't care. We would care over there, but I don't care over here, right? You understand? I don't care over here. It's not going to hurt anything.
But that was a simulated back out.
No, it was just a simulated setting it back to 0.
Yeah, but it didn't run through nothing.
Well, it could have.
The way you did it like that, though, it didn't.
Well, it might not have, but what I'm trying to say is I could be anywhere. So let's say I come back here and I'm sitting way over here for some reason. So let's put it back on rectangular jog, and let's just send X out plus. Let's take it off each. We'll do this. Okay, then we'll bring it down Z. Okay. Well, yeah, but I collided, but it's not going to hurt anything. What I'm trying to show you, it don't bring it out. It just brings it out. Is what I'm saying. So now if I do this, if you can see this fast, you're really good. So if I go like this, did it collide? I don't know. I don't care. This is a simulation. You understand what I'm saying? Now, if I was to do that over there, that's going to cause problems. But over here, don't cause problems, right? You understand? So getting it back to the home position, and I'm going to show you another way you can do it, especially if you want to reteach points. how you would actually reteach the same point. Okay, so y'all know how to teach points, right? How do we teach points? We jog it to where we want to go. You can either jog it over here or you can jog it right there. It don't make any difference, right? You understand? If you put it on pulse, it's going to jog joint, which over here they call what? Link. If you put it on robot, it's going to jog relative to the robot. And normally base is going to jog relative to the world. And then I can come over here. And by the way, you change your step size right here. So this will be the jog speed. Does that make sense? And then now I can come over here. If I want to move plus X, I can come up here and jog the robot here. Can y'all see it moving? Now what's nice about jogging over here is you actually see the what? You actually see the position of the robot. Y'all understand that? But we don't have a tool jog over here. All we got is Cartesian, not relative to the tool. If I want to do a tool jog, then I'll put the tool over here and I'll jog over here. But you got to be real careful because over here, if you have it set to fast, you come over here and say minus Z or plus Z, see, and you hit it, it's going to be down. It's going to move fast, right? Go ahead, Kathy. Huh? Yeah, inch or slow. Or click it. Fast is going to move in pretty good increments. So if I come over here and say plus, see, I can hit it one at a time. You'll see what I'm doing, but it still moves in long distances. Even if I do it by just hitting it, then I can come over and go to these slower speeds. You can see it's actually doing it in increments. Can you see that? It's just that when you go slower, the slower the increment gets. Or if you just hold it down, it's going to do it. So it's just like y'all over there. So when you're trying to get close to something, what do? You just bump it a few times to get it in there. You put it on slow, but still you bump it to get it precise. Are we okay? All right. So how would I teach a point? So I'm going to go over here. I'm going to go from start again. I'm going to take all this off. And how do I open a new program? No, that's a new cell. We're going to do a new program. So I'm over there on that robot over there, very similar to what we do over there. So what I'm going to do is I'm going to go to robot, I'm going to go to controller, and I'm going to go to select a job. So when you install MotoSim, it by default puts a job in there called default. Okay. And then right here where it says now MotoSim jobs gets a job on the computer gets a .jbi extension. We talked about extensions a little bit, right? And that's why we turn them on when we run MotoSim so you can see these extensions. What am I going to do is I'm going to come up here to default, and what do y'all want to call this? Let's just call it new. Right, and I'm going to say OK. And then it jumps back here. I bring up my controller and see my controller is basically blank. These two instructions is what we get automatically. Normally when you start a program, it's got to have at least one thing. It's got to say where the program ends, right? So every one of these robots, normally the last instruction is automatically sticked on there called end. They might call it a little different. Motorman puts an instruction at the first. We called it no-op instruction. That's no operation. So it's a valid instruction. Okay. So what I want to do here. So I'm going to go back to pulse and I'm going to zero this out so I can teach my start position, right? Okay. Now how do we teach point? Well, yeah, okay, we can do that. So let's say this is my start position. So normally how do we move to our start position? Real fast, right? We move to our start position fast because we're not near anything. So what we try to do is if we're not near anything and there's no collisions and we don't have to be precise, we're going to move that robot as fast as we can, right? Y'all understand? So how do I do that? So it's at the right position. How do I teach a point? So this is what you're going to do when you take the test usually. This is what you're going to do. You're going to start a work cell. You're going to import a robot. You're going to teach a job. And you're going to set up collision detection, which we're fixing to get into. Huh? So how do we teach a point? Huh? Okay, we're going to go to move, and we're going to say, okay, what type of instruction do we want to put there? What's the fastest I can do? So what is this? This is a type move. I click that down. These are all the moves that's supported by a MotoSim. Now I'm going to set the what? Speed. Okay, and this is percentage, right? You understand that. Then what I'm going to move over here, and I'm going to set the position though. This one I don't care, so I'm going to set it at 7. This has got an 8, but I don't think that the robot doesn't have an 8. So let's, and we're going to click on OK, but that still hadn't taught the point. What do we need to do? Yeah, this is just like the Motorman. Hit add and put what? Enter, and it pops the point in there. Then what would I do? I would jog the robot where I want to go. So what we got to do, first of all, we can't go from here to here. And y'all see why? It'll collide. So what are we going to do? We're going to teach a staging point. So we'll jog the robot out. This don't have to be extremely accurate. So what I'm going to do real fast is just spin it around so I can see. Let's look at it from the other side. So y'all know how to get different views, right? They show you 4. You can hit on the little camera, and you get a lot of different more views that you can look. Okay. So I'm going to look at it. The standard views is this one. So what I want to do is I want to jog it out till it gets past this top right here, this vertical here. So I'm going to go, I hope not. Yeah, I'm going to go plus X and move it out. No, we don't want to go down yet. We don't want to teach a point down, because if you teach a point down, you're going to collide. This is where I want to teach a point, but I want to teach it pretty close to where I want to end up at, right? So I'm going to move it to the front, and where's our first well? Our first well is going to be right here. Okay. So I'm going to go over here. I'm going to jog it to the left, so I'm going to minus Y, and I'm going to move it over till it gets pretty close to lined up. We can zoom in to get a pretty good picture. This is the way we zoom in right here, right? Come up here, just box in what we want to do. Okay, so it looks like I want to go a little further, right? And that looks pretty good. So what am I going to do?
Roll it back.
Why?
Turn the picture so you can see if it's clear.
Oh, we did that first. That's a good idea, but all I did was go why. So my first thing is I checked to see if it was cleared, right? You understand? So here, don't look here, look right there at the, don't look here, look right there. Here's the tip right here. Is that cleared? No, it's not. No. So here we're going to add a joint move. I'm going to add a joint move right here. All right. 100%. Then what I do? Then I'm going to bring it down minus Z and stage it. By the way, these are, let me bring this in right here. What we have the ability to do, they call it teacher. But what we have the ability to do is we have the ability to pre-teach points. And they call it teacher. And let me zoom in, and you can see the frames. These are the teacher frames here. See them? So this is on this corner. This is on the other vertex right there. And notice we have the angle of the torch set. So not only can you pre-teach the point, You can also pre-teach the angle that you want the torch to come into. So we're going to come in and bring it down just a hair, so we can line. What I'm trying to do is line this up with this right here, right? Or close. That looks pretty good. So that looks like a pretty good staging point, right? So what I'm going to do, I'm going to teach this point. We're going to use a joint move, but what we're going to do is we want to hit this point because we don't want it to start curving, so I'm going to set it to a what? Position level 0. And then I'm going to do what? I'm going to add it. This looks like a good staging point. I mean, you might want to teach a staging point a little closer, but we're going to do a linear move and it comes straight down, right? So what I'm going to do here is I've got my torch lined up and everything. So what I'm going to do is I'm going to swing it around so I can see the front again. I'm going to come up here and turn on OLP. I'm going to zoom in. And this is what's so neat is I can just come over here and turn it, make sure it's on. And then I'm going to come up here and hit this point. I've got it set up for the what? The vertex. Come over here and just get close to that perk and it goes perfect. That tip is actually touching that point. And then I'm going to come up here and change this over to a linear move. Change the speed to whatever, it's in the lab what to set it at. 11 millimeters per second is okay. And this is, we're going into the work, so we're going to set it to a position level of what? 0. And come in here and go, okay. And then we'll add that. Then what would I do? I'm going to move it over here. Try to move it over here, guys. Turn off OLP. I'm going to come over here. Come down, turn OLP back on. Get right there. Came to the vertex there. And what I'm going to do, set my speed. Make sure my speed is what's required. And teach the point.
So that'll take from vortex east to what part?
Yeah, because we're saying, okay, I'm going to go to this point, and then I told it to move to that point. Because all we do in the robot is teach points and tell it how to move from the previous point, right? You understand? So no, it's not going to jump out. It's not going to follow the path that I jogged it over there. I said take a linear move from that point to what? That point. It don't care how you jog and get it over there. Now, on the real robot, what we would do is we'd back it out and move it over and bring it down a touch again, right? But this is not a real robot, so we can use the OLP. Now, what would we probably do? We would probably back it out and then bring it up. But what we're going to do, I think in the next lab, is we're going to back it up, spin it out, spin the torch around so we can weld on the other side, bring it in, set it down, and weld the back side. So that's what we'll finally end up doing.
So when you're going right down the point, you just making a little spot on each point.
No, we're welding. I didn't say back out. I said, what's this right here? I'm going to open this up. What's this? That's a linear move right there. That's where I taught that. That's a linear move right there. Did I back out? Did I tell my robot to back out between that point and that other point? No. So don't get confused without how you jog the robot with what path the robot is going to take. Y'all understand? Don't get confused with the path the robot is going to take. Now, are y'all paying attention to me? Because y'all are going to be required to know that. The Morgans, are y'all paying attention to me? Okay. So y'all need to, because this is going to be on the test. And when is the test? No, Tuesday. In this class, it is Tuesday. Right? Ain't it Tuesday? No, I said it wrong. I said advanced PLCs is going to be on the 2nd, not this class.
Thank you for that.
I might have said Tuesday, but I did say the 2nd. This class is done. So how do we run the program? Well, y'all ain't done it yet. No, not on this robot. What we do, this is play right here. You're right. We would, over there, we would switch it from manual to auto. Over here, we don't have to do that. Notice what happens when I hit this button right here. Program resets to the front. So let's swing it out a little bit so we can watch it. We'll put it at a sort of an angle, and then I'm going to zoom in, and I'm going to hit this. And we just ran the probe. And what's so neat, if we had this robot here, and we had this thing over there that was exact dimensions, the dimensions got to be exact as your model, we could literally take this program and go over there and upload it into that robot, and it would run. And we'll see that when we get to the robot. Huh? It's given in the lab. So the dimensions we give in the lab, this is what hopefully y'all have this built already. So when they told you, we gave you the dimensions, right? We changed the dimensions of this because the robot can't reach over it with this torch on there. The robot could reach over it, but it's got this big old torch. Okay. All we did was change this from 600 millimeters down to 300 millimeters. All the other dimensions were the same as in the lab. So in the test, it's just going to say, we're going to build. By the way, the test, we just use a box. We don't build the workpiece. We just build a box. So hopefully y'all know how to do that. And this is what I'm saying. When you go through that thing, people have a tendency of blindly following the instructions, and they don't learn from what they do. And then when it gets time for you to have to do it, then you got one of two things. You can go back and try to look at those instructions. It's just like what we talk about the NEC test. The National Electrical Code is a open book time test. But if you have to go up there and you have to look up everything, you're not going to finish the test in time. So they expect you to know a lot of stuff. And of course, here we give y'all this quick reference, right? Which should help you, if you can read it, come back and do that. So what we're going to do now is we're going to set up collision detection, which has nothing to do with that robot over there. That robot don't have collision detection, right? Well, sort of. But what we have the ability on a real robot is we set what we call torque limits. We can set torque limits on the robots. So if the motors start pulling too much current, it knows it's what? It's jammed up against something. And we shut the robot off. Normally that doesn't hurt the robot, but it might hurt the tool. So we got to be real careful with that. What we're going to do is we're going to come up here and notice when we hover over the toolbar, over the ribbon, if we leave it long enough, it'll come up here and it will show us what each one of those little icons do. So this guy right here that looks like something touches something, this is collision detection. So when I set up collision detection, I'm going to come up here. What we do is we set up what we call pairs. And it's more than one. We have what we call a master, and then we have what we call slaves. So the master is what's in motion, and the slave is what we could collide with. Does that make sense? So I'm going to add a pair. I'm going to come up here and add a pair. And what would be the master to start off with? What would you think would we set up as a master? Yeah, the torch or the tool. Okay. All you have to do, by the way, you can come over here in the cat. So I'm going to come up here and get this guy right here, select a model. And then I'm going to come down here and just go to my torch. And I'm going to touch it. And it automatically puts that name of that model right there. And then I'm going to select it. See? So notice when I touch the box or I touch that, it automatically comes in, and or you can do it in the CAD tree. The problem we have is we definitely want to collide with the floor, but select model will not select the floor model. So what I can do is I can come into my CAD tree and I can touch on it in the CAD tree and it pops up there. So you got two ways you can select a model. You can select it in the CAD tree or you can use this select model right here. Everybody okay? Of course, we're going to set our master as the what? The tool. Yeah, I'm going to come up here and set this as what? Master, and then I'm going to add. Now everything else is going to be slave. So what could we collide with?
Work.
Okay, so I'm going to come up here and I'm going to touch on that. And then I'm going to go to slave and put what? Add. Just touched on, yeah, whatever you think you can, whatever you think you're going to collide with. Of course, we got to probably touch on this too. Okay. I know it's all part of the same model, so we're okay. We could collide with the what? With the table. Okay, so I'm going to come here and make that a what? Slave. Or we could collide with the floor. So, but it don't work. So what we're going to do is just go to the what? Yeah, we're going to go to the CAD tree, click on floor. I'm going to add that. What else could we collide with? Well, we could collide with some of the joints on the robot. So eventually we would come up and do that.
Okay. Well, you wouldn't do two of those for the vertical part or the flat part?
No, it's all one piece. It's all one model. If you remember when you built the model, you put two boxes in this model. You put this box and this box. So if you put everything you put in the same model is considered to be part of that model. Understand? So if I come up here and look, okay, so there's work. Well, work actually consists of this many things, right? You understand? This is Axis 6, by the way. That's your teacher that we'll talk about later on. So if it's part of a model, I don't have to select each part. It knows it's all the same model. This is what y'all add later on, by the way, when you start teaching your program. So right now, if you looked at your model, you would have two boxes in it. So you got two ways you can select it. So y'all probably don't have teacher in here yet. So this is where we can pre-teach points. We can go in and we can set the angle of the torch and all kind of neat stuff. It's really, really neat. I don't use it that much, but it'll use this when you in your program. Just see how to do it, right? Okay. So I know the robot can hit itself, so if I swing the torch around, so I might want to, it can't hit this, it can't hit that. It could probably hit this, right? It can't hit this, but it can definitely get into this down here. So I might come down and add, these as slaves. Okay. So now what I'm going to do is I'm going to come in and what we need to do, so before you do anything, you need to do what? Register it. And it says, okay, and now that I've got it registered, I can close it. Oops.
Did it register?
Didn't.
You didn't have a file up here now.
Oh yeah, I didn't give it a name. So what we're going to call this? We can call it tool. Thank you. I'm not looking. So let's go back real quick. Master is a tool. It took that. And what I'm going to do, I'm going to set up so anything that it can, so what's in motion, we set that up as the master. What it can collide with, we call those slaves. And like I said, it's real easy to do. We just use the what? Just use this select model, or we use if we can't get it with the select model, then we can get into the CAD tree. Later on, we're going to start building this over here. We can collide with the glass. It's not glass. We can collide with the plastic, but the problem is that when you put the plastic in there, when you select something on the robot, it tries to select the glass every time. So what you can do is, if you can't get to it because you put something in front of the robot, right, you understand, then you can select it in the CAD tree. Or you can hide that model. You know how to hide models, right? Showed you how to do that.
I want to be ready something that you want to do.
Yes, let's go back. So let's come back and, I'm gonna click on that, work, I'm gonna do what? Add that as a slave. I'm gonna click on this, add that as a slave. I'm gonna go, well, the robot will do later. Let's just get through this, floor. I'm gonna come on my CAD tree and I'm gonna, add that. Then I'm gonna come up here and I'm gonna register that. I gave it a name. And then we go back and close it. And notice now I have something registered there. Okay? Okay.
Do you have to call it that?
You can call it anything you want to. It's if you don't want to call it a tool, that's fine. It's just you need to call it something that you know what model it is. Right. Okay, any more? Look what we got here, Kathy, available to us. We got what? We got edit. So if I want to edit, I can select it and go back and add more models if I want to. Or I could do what? I could delete it. I could delete the whole thing. Or if I could add another pair. Are we okay? Okay, so what we got to do now is we're going to come up here and we're going to do what?
Let's collect the collision check.
Yeah, collision check. Right now it says I'm colliding with that. Of course, we knew that because the wire is touching, right? So what I'm going to do is I'm going to come up here, and so sometimes you're going to get collisions, but they're collisions you anticipated. Now I'm going to jog it plus X. Now as soon as I do this, and I need to go minus Z. Oops. So now it's not colliding. So now I should be able to come up here. And if I come up here and touch something, so let's go minus X. As soon as it touches, what? Okay. So, but what we're doing here, this is a collision in a simulation. What did it hurt? Nothing. But if we create exact or precise models, that means if it collides over here, it's going to do what? It's going to collide over there. But what we can do here is we can see if it collides, right? So if I send it somewhere and we see that thing turn red when it goes over there, we know it did what? It collided, and we're going to have to do collided. And we're going to have to do what? We're going to have to adjust our path. But we do that over here, we don't do it over there, which is pretty neat. So that's what we call collision detection. It's not that hard to set up. So what do we use? Use this right here. Use two things. Use this and also use what? That. Yeah. So right now, by the way, when you and of course you can always turn it off. By the way, the robot this is built into the robot. So if we jog our robot, so let me take it back on. I'm gonna take this back to short so I can get my stuff back. I'm gonna go to link, and what we're gonna do is we're gonna start spinning this guy. Oops, wrong thing, Bridge. And when you see it turn, when you see it turn orange, you'll see it. And what they're doing is, we have it set for what it means. It don't really mean you collided. What it means, we're at 95% of the maximum motion of the robot. Are we okay? Any questions on that? Collision detection. So we showed y'all how to do what? Teach a point. Everybody okay on teaching a point? We told y'all how to play the program. By the way, single stepping, all you do is just put it up here and just do this. Go through that. That's all you do is use your arrow control keys on your keyboard just to step it, or you can come up here and click on a point and it goes to that point. So here over there, we literally have to single step, right? You understand? Over there, if I want to verify that point there, I can just click on whatever point. or I can just go forward or backwards in the program just by using the what? Using the arrow keys. Y'all know how to create a program? Where do we create a program at? No, robot, controller, select a job. Okay, notice that job is in there. I can come back and go back to here. Oh man, I lost my level 1 job. I don't know how I did that. And then later on, we'll show you how you can actually see the jobs. In fact, I'll show you that. What I'm going to do is let me shut this back down so I can get to here. Just to show you the information that's recorded in a job. I can't get my taskbar to pop up. There we go. So when you actually write a job, this is good enough. What extensions does the job have? JBI, right? I'm going to go inside the robot folder, and there's the job right here. Normally what we have to do is open this with, it's a text file, so we open it with, so this is actually the job. This is actually the true job. So what I want you to notice is that right off the bat, the tool that you have selected when you teach that job is in the program. It's actually part of the program. So that's why you can't go over there and select a different tool, right? Does that make sense? These are all our points. These are the actual encoder readings of the points. And then this is the actual program right here. Very similar to what you see over there, but all this additional information is actually part of the job. So I just want to show y'all that. Because once you learn a lot of stuff, you can actually edit your job over here. But you got to know the right syntax, right? You got to know. Here's another job. See, every job you record the what. You record the what. Okay, guys, any questions? And that's kind of what's going to be on the test. So what are you going to have to do on the test? Yeah, you teach a job. And the review is already up there, by the way, for this class. So I'll show y'all what you're going to have to do on the test. So you have to create a new work cell, add a given robot model, create a new job, add the provided tool model to the robot flange, create a model of a box, a workpiece given the dimensions, set up collision detection between all moving parts of the robot with a box, work cell, floor, teach a job, a start, a staging, then we'll go around the box, kind of like one of the first programs y'all did over there. Second staging and return back to the start.
So basically everything now.
If you get through this lab. You know, if you don't get through this lab, it's still going to be on the test. Because y'all understand. Most of y'all are going to have no problem getting through with the lab because we got 2 days. So some of y'all are actually should be past this point. You should be working on a lab after this. But what I'm trying to say, but if you're absent, I'm sorry, we can't compensate for that, right? You're still going to have to take the test. It's going to be a time test. Have 2 hours to complete it. And then after that, you're going to turn in and it's going to be graded wherever you're at. 2 hours to do something that if you understood this thing and you practiced and knew it, might take maybe 30 minutes. If you don't have to look up everything. If you got to look up everything, you're not going to finish the test. Y'all understand that? And that's like a lot of time open book tests. A lot of open book tests are time. And what that is, if you have to look up everything, it means you didn't learn anything while you was doing it. You just followed instructions and did not know what you were doing. I think I told you about us buying that electronic kit for my son. And the instructions told him exactly what to do. Every circuit he put together was perfect, but he had no idea how they worked. Every one of them worked, but he didn't know why. So there's a review for the test. Everybody okay? All right.